Okay, this is example 2 out of chapter 11, box B here. And this question is almost, well, it's very similar to what they're asking you to do in the question on page 11B4. So you should watch this lesson, then go to page 11B4 in your guide and try the question there. And what we have here is we have a situation, a description of a situation, and we want to draw the graph that is going to match this situation. Okay? So here's the situation. Chad goes for a walk. He leaves home and walks for 150 meters at a speed of 30 meters per minute. He then speeds up and walks 300 meters at a speed of 50 meters per minute. He pauses to rest for 2 minutes, then he heads straight home. And it takes him 6 minutes to get home. We want to draw the graph that represents his walk. Now, when we were drawing, when we were describing what was going on in a graph, what we did was we had sort of one sentence for each section of the graph. It's going to work the same thing here. Each sentence in this description is probably going to translate into one section of our graph. So we're going to have section 1 here, him leaving home and walking. Then we're going to have section 2, him speeding up. We're going to have section 3, where he pauses. And then we're going to have section 4 here, where he heads straight home. So we're going to have 4 straight lines that are going to make up our line graph here. Before we can draw our graph, we have to do some calculations here. So we are dealing with distance and time and speed in this question. So we have to remember that speed, if we wanted to calculate a speed, that would be distance divided by time. So if we want to calculate time, which is what we're going to want to do in this question, time is going to be his distance divided by his speed. And they give us some questions here of things that we should calculate before we draw this graph. So the first thing it asks us is, how long does the first section of the walk take? So that first section is him leaving home, walking for 150 meters at a speed of 30 meters per minute. They give us 2 things. They tell us his distance, or D, is 150. They tell us that his speed is 30 meters per minute. And they're asking us how long this takes. So we want to calculate time using distance divided by speed. So if we do 150 divided by 30, punch this into our calculator, we get 5. Okay? So this section of his graph, the total time, he's now been walking for 5 minutes, and how far has he traveled? Well, he's traveled 150 meters from home. So we could come down to our graph here and we could draw this in. Okay? We've got time down here. We've got distance over here. He starts right here, and we go over 5 minutes. 1, 2, 3, 4, 5. And then he's traveled 150 meters, so we go up to 150. Okay? And we're going to connect those 2 points with a nice straight line. So I'm going to make mine red so that you can see it, and we'll just go from there to there. Okay? So there's the first section of his walk done. Okay? 5 minutes, 150 meters. How long does the second section of the walk take? Well, again, we want to figure out, in the second section, what's his distance traveled and what's his speed. So what's his speed in this second section here? It's given in the description. How fast is he going in section 2? Drake, what do you think? Okay. Does it give us a number? Logan? 300? Now, is that his distance or his speed? 300 what? 300 meters, so it's going to be distance. So his distance is 300. What's his speed? Riley? 50. So how do we figure out time, or how long it takes? Well, we're going to do 300 divided by 50. That's going to give us 6. So the second section is 6 minutes long. So if we want to figure out how long he's been walking in total, we have the 5 from the first section plus the 6 that he's gone in this section. So he's been walking for a total of 11 minutes. And how far has he traveled? Well, he did 150 in the first one. He does another 300 in the second one. So now he's at 450. So the point that we want to go to is a time of 11 and a distance of 450. So let's see. Time should be 11. Distance should be 450. So that's right there. And let's draw our straight line up to there. Now, if we compare these two lines, is one of them steeper than the other? Riley's nodding her head. Does it make sense which one is steeper here, Drake? The second one's steeper. Does that make sense? Yeah. Why does it make sense? Well, when was he going faster? It's going faster, so that line should be steeper. Okay, we're on to the third section of the graph here. What happens in section 3 here, Drake? Okay, third section. So where's our description for the third section? It's right here. He pauses to rest for 2 minutes and then, well, he pauses for 2 minutes. So what's the line going to look like? Yeah, it's going to be flat. So it's 3 minutes and it's going to be flat. So it's going to go to, well, let's see, if we had 11, we add on 3 minutes. So we're at to 14 now, and the distance doesn't change, 450. So we want to end this section at time of 14 and a distance of 450. So we can draw that line in as well. Make sure I get this red. And this is going to go straight across. Okay, what happens in the last section of our graph here? Section number 4, Riley, what happens here?
It takes him 6 minutes to finish.
Okay, so how should this line look? Where should it go? From this point here, where should it go to? To 20? Okay, because we were at, well, we were at 14, right? And it goes to, why does it go to 20? It does go to 20. Why, though? How long does this section go? Not 5 minutes, but 6 minutes, right. So it takes him 6 minutes to get back home. So if he was at 14, and we add on those 6 minutes, he's at 20 minutes. Now, why did I put it way down here? Okay, why is this point down here at the bottom? Because he's what? He's gone back to home. So he's moving back towards home. So we just have to draw on this last line, and that completes our graph. Ta-da. And there is our distance time graph representing that situation.